Sass class with Amanda. Hey. Hello, in this video we're going to use our T procedures on examples. So they're called T procedures. I don't know why this lead's so thin. Oh, much better. Alright, so the learning objectives are to find a confidence interval and to conduct a test of significance. Alright, so here we'll learn how to use table C. So first, I'm giving you degrees of freedom, 999, and we want to find the T-star that gives us a confidence level of 99%. Okay, so it's very similar to how we were using the table before. So we want to find the 99%. We see that it's this column here. And so now we want to use the column on the left, which designates degrees of freedom. So we're looking for 999. The first thing you should notice is that there is no 999. So once you get to, I guess, 30, you can start rounding to the nearest degrees of freedom, because notice that these values don't vary a whole lot. Okay, the difference between the two gets smaller and smaller. And like I said before, T distribution gets closer to the standard normal distribution as n increases. So eventually we can just use the z-star row. But right now we're not close enough, we're not over 1,000 or very far from 1,000. So 999 degrees of freedom can be rounded to 1,000. This is the row we're looking at. And we know that 99% confidence is going to be this column here. So we have that T-star is 2.581. So T-star is equal to 2.581. All right? And so hopefully this example helps you understand the process. All right, so our confidence interval, if we're going to write it for this, it would be x bar plus minus 2.581, because this is replacing our T-star, times s over the square root of n, and we know that n is one more than the degrees of freedom, so this is 1,000. So actually we could figure out a confidence interval here using an earlier example where I gave you an x bar and s and an n that was 1,000. You should go ahead and plug that in and make sure that you trust that you know how to substitute and plug things into a calculator. Alright, so the next example says for a test of significance, we're going to have a degrees of freedom of 14 and a t-statistic of 2.12. And what we want to do is find the p-value. Remember, for a test of significance, step 1 is state H0, step 2 is state HA, step 3 is find the z-statistic, but since we're dealing with t, it's going to be a t-statistic, and we're given that already, which is nice. And then step 4 is always find the p-value. Okay, and step 5, which looks an awful lot like 5,5 instead of S5. So step 5 is going to be compare the p-value to your level of significance and conclude. Alright, so this is just a review for our steps for a test of significance. And so we want to take our t-statistic and our degrees of freedom to find the p-value. So let's go to the degrees of freedom row. Okay, so degrees of freedom is the leftmost column. We want to go down to 14, okay? And we know that our t-statistic is the value 2.12. So we want to find where 2.12 lives. And 2.12 lives right here between these two guys, between 90% and 95% columns. Alright, so to find the p-value, we're still going to go down to the p row. Okay, so we're going to follow this down to the p row. Remember, we're between these two columns. Okay. And we're going to go down to the one-sided and two-sided p. And depending on what our alternative is, because you still have one-sided alternatives or a two-sided alternative, our p-value is going to be less than 0.10 or 0.05. And so we still have statistical significance at a certain alpha, right? So hopefully that helps you understand how to find the p-value. Now we'll do a more thorough example so that you can see how it works in action. I'll just choose a different color. Alright, you are interested in determining whether the average number of calories people eat is higher than 162 for breakfast. You believe it's higher. It's all those waffles. You ask 5 people at work and you find that X bar is equal to 169.8 and S is equal to 47.86. So notice the data is given to you, okay, so we even know what N is equal to. N is equal to 5. We have X bar and S. Is your evidence strong? So this is a key phrase telling us that we're conducting a test of significance. All right, so our null hypothesis is that mu is equal to 162, because this is a statement of no difference. And our alternative is that mu is greater than 162, because that's what we're claiming here. All right, so step 3 is to find the t-statistic, and we said that t is equal to x bar minus mu 0 over s divided by square root of n, and x bar is 169.8 minus mu 0 is 162 over, we're given s is 47.86 divided by square root of n, which is the square root of 5. And so you can plug this into the calculator to get, so you'd get 0.3644. Actually, I just want to go to RStudio real quick and show you how easy it was for me to do this. So 1.69.8 minus 62. So recall, you need to use parentheses. And look, I don't even have to use that, like figure out in a calculator how to deal with the square root. I could just plug 5 into the square root function. Amazing. All right, now going back to the problem. So we have t is equal to 0.3644. We know degrees of freedom is equal to n minus 1, which is equal to 4. All right, so now let's go back to the textbook, find row degrees of freedom 4, which is right here, okay? And we want to find where our test of significance, or sorry, our t-statistic lives. And remember, our t-statistic is 0.3644. And so as we move to the right, our t-stat is larger in value. So that must mean that 0.3644 lives here. And what does that tell me about my p-value? Let's go down. And we know that this is a one-sided p because we're talking about being greater than 162. So our p lives here, and that tells us that our p is greater than 0.25. So our p is greater than 0.25, which implies evidence is not strong, and we cannot reject H0.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife, the implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.